Okay, so we're going to just do some notes for chapter 6 here. The first thing we're going to define is what a scatterplot is. So this is the most common display of data, like, known to man. I know we've all seen these. You're all going to be like, it's a thing with dots, right? But what it really is an x-axis, right? And a y-axis. And we plot some values against one another. So we plot two categorical variables at the same time. So it's I just said categorical. I meant quantitative variables graphed at the same time. The x is referred to as explanatory, or the predictor, or it used to be like our independent. And the y, I'm going to put little arrows because they look like they're negative for some reason. I don't like that. Okay, and the y is referred to as the response variable. Right, so x is explaining what's happening and y is literally responding to it. So some of the exercises in your homework are going to ask you which makes more sense, like this to be x and this to be y, or the other way around. And so it might be our job to kind of determine which is the most effective relationship. Okay, so I do want to talk about the three features of a scatter plot. So there are three ways to describe any scatter plot, and this is kind of like back in chapter 2, I think, when we talked about describing a histogram. I think that's chapter 2. There were three questions we kind of asked ourselves. This is very similar. Okay, so the first question is what is the direction, right? So it looks like to me it's going up or it's going down, right? So it's either increasing or it's decreasing. And if it's increasing, we say that the direction is positive. But if it's decreasing, we say the direction is negative. Okay, so that's usually relatively simple. If you look at my little example that I made up in the top right, most of us would agree that that appears to be positive. The second question says, what is the form? So the form is whether or not this appears to be a straight line, right? Or a cloud of points, or a cloud, no pattern, or even a curve, right? A curve is not a straight line, literally something that is curved. So if we say that this looks like a straight line, then we would call this graph linear. And if it does not look like a straight line or follows one of these other descriptors, we would refer to it as nonlinear. Okay, third question is going to go on the next slide. So our third question is what does the strength of the picture look like? So are the points tightly, I'm having trouble writing on my whiteboard at the top, clustered, or far apart, right? So tightly clustered is going to be strong, and far apart is going to be considered weak. So we'll have like three words that would go along with each picture, either positive or negative, linear or nonlinear, and then strong or weak. And the other thing that we like to talk about in terms of scatter plots and their relationship between the variables is correlation. So this is actually talking about the strength. The correlation refers to the strength of a linear relationship between two variables. So let's make it specific, right? Quantitative variables, okay? So it talks about how strong the relationship is, but not just any relationship. This is like specifically two variables that when graphed appear to look like a line. That's when we refer to correlation. If we're talking about just two variables that look like they're related in some way, like maybe there's a curve or something like that, then we would refer to that as an association, not a correlation. And so there's some stuff that we have to kind of talk about in terms of correlation, and that's its measurement, which we refer to as the correlation coefficient. Okay, and like, wouldn't it make sense for it to be the letter C, but it's actually the letter R. All right, and the correlation coefficient measures the strength of the correlation. So it's a literal number representing the strength of the correlation. So I'm going to kind of draw a little range of values here. There's serious restrictions on R. R can only fall between -1 and +1. So the minimum value it can be is -1, and the maximum value it can be is +1. And the number lying right between those two is 0. So hopefully we all understand that when we look at this picture, we see a couple things, okay? Over on this side, all my numbers are positive. So everything over there would have a positive direction. Over on the left side, all my numbers are negative. So everything with the correlation coefficient below 0 would be described as negative. Let's see. Closer to 1 is considered to be strong and positive. Close to -1 is also considered to be strong, but that would be a strong negative correlation. But when we get here in the middle, closer and closer to 0, right, we get weak. And so everyone's always asking me for some kind of a range or something like that. And I always say, like, if R rounds up to 0.7 or -0.7, consider it strong. Okay, so if we have something that's closer to 0, so between 0 and 0.7, I would not consider that to be super strong, and I might not move forward with my linear relationship here. All right, one final comment on the next slide, and that's how we're going to do this in our calculator. So we've got a couple steps we got to write down on our calculator. So calculator steps. Finding R. Whoa. Okay. So what we have here is we want to find R. And we're going to need to use the linear regression feature in your calculator, which looks like this. However, we first turn your diagnostics on, okay? So if you have a newer calculator, so if you have a TI-84 or more, right, that's an 84 plus or whatever, you should be able to go to mode, arrow down, and then make sure your diagnostics are on and not off. But if you have an 83 plus, then you need to follow the following steps. Second, the number 0, hit the X to the -1 key, and then arrow down until you find diagnostics on, and then hit enter twice. Okay, so you turn your diagnostics on, then you'd put your data into L1, which is your X, L2 would be your Y, and hit stat, arrow right to calculate, that's an arrow, and select option number 4, which says linear regression. And then most of us can either hit enter or arrow down to calculate, and R will be the very last value. R is the last value in a list of 4 values. Okay, so this last slide is only about the calculator. We will practice this together in class, I'm hoping. Keep up the good work.